Let me just see. Okay, we're getting into the exercises. Why is this thing on? So in the chapter 6, in the exercises download, you will find a text file that is called data.csv containing some made-up data for a number of genes. Each of the lines contain the following fields for a single gene in this order. So it's first going to contain the species name separated by comma, by the sequence, then the gene name, then the expression. The field is separated by commas because it is a comma separated file. So exactly the way it says it here, it's going to give species name, sequence, gene name, expression separated by commas. And you could think of it as a spreadsheet, so an Excel sheet, where there's this will each represent a column. There will be rows with different variations of that. And all of the exercises that we're going to do are going to come from that file. So the first exercise that they ask you to do is to print out the gene names for all the genes belonging to Drosophila melanogaster or Drosophila simulans. So in my case, my file, I stored it in where the script is. You would have to specify wherever you downloaded the file. If it's on your desktop, you would obviously stop here, and this would be your username. For line in file, so I've opened the file. I always strip. We've learned this before. If you just use .strip with empty, it's going to strip empty lines from either end of your line, and we are splitting it in a comma because it says that it's a comma separated file, because we want to create columns. So then, because we know what the sequence of the data is in the file, we say we know that the species name is in the first column, which is indexed or position 0, and we know that the gene name is in the third one, or the 0, 1, 2 position in terms of coding language. And those are the two ones that we are interested in here, because they want you to print out genes or the gene names for the following species. So we know that we need species and we need gene names. So all you're going to say is, if the species in column 0 is equal to either Drosophila melanogaster or Drosophila simulans, then you're going to print out the gene name. I just put species as well, because like I said before, that to me it's important that I have some checks in place. Obviously, after you've got, you know that your script is working well, then you're only going to print out the gene name. Okay, but you can see that it printed the Drosophila melanogaster twice, because it was found there twice. Okay. Then exercise 2, it says print out the gene names for the genes that are between 19 and 110 bases long. So they're not giving you, they're expecting you to kind of understand how you, where, in which column you're going to find the information. And we know that to determine the length of a gene, we need to know how many bases or nucleotides are in this gene, which is its sequence. So they're not telling you that it's there, but they expect you to kind of understand from the way the file is shaped that you are going to be looking at the second column, or column 1, right? So in coding language. So again, here we've got the sequence. This is exactly the same as the previous one. All I pulled out was the sequence in column 1 after I split it into their columns, and the gene name in column 2. And then I said, I'm going to need to know what the length is of the sequence. So I used the len function, and I stored it in an intuitive name called sequence length. And then all I did again was to say sequence length. Now you can do this in a longer step, right? You can say, you can use or, but I'm just using the normal way that we learned it in math, in arithmetic, where, you know, I place both of them into one statement. But you can say, this is asking if it's between 90 and 110. So you would use, because it has to satisfy both. So this would have to be, and they wanted more than 90 and less than 110. So you could do it that way, or you can do it this way, and it should produce the same result. Okay, then exercise 3, they said print out the gene names for all genes and AT content less than 0.5 and expression levels greater than 200. And again, this is what the file looks like. This is an example of it. And everything is more or less similar. The only thing that we're doing here is we are writing it into a function, because we've done this so many times now as is. So again, they are not telling you exactly what to do, because they assume that you're going to use your logic to know that you're going to have to get the information from, even though they don't say sequence anywhere near, they know that you are going to get all your information from here. And then obviously the gene name. So in here you will do your converting everything to dot lower or dot upper, but then you'll have to convert this to dot upper. It's probably better to convert it to dot lower, since this is already all in. Otherwise you have to convert all of that to dot upper. So just stick to, I normally match my script to what is in the file that I'm reading. So I'm going to convert everything dot lower to dot lower, and then you do the normal arithmetic. Note, I just rounded this to 2 because it's easier to read. And then it's going to return the AT content, which is a float in our case. And then, yeah, you open your file. You say for line in file, open file. We've done this before. If you want to read it in line by line, you're going to open the file, and then you're going to say for line in file. Again, I strip empty spaces from both ends. You split it on a comma because you know that it's comma separated. And then you pull out your G name because it wants you to print the G name, and you pull out your sequence, which is in 0, 1, after you split it by comma. And then your expression, because they want you to also print it if the expression level. So this here implies that they've done some sort of gene expression, which those who do biology will know about. So if the gene has expression levels above 200 or greater than 200. So yeah, I've extracted this from the file using -1, because again, we've done that. If you want to extract from the back, you can put in -1, but it will also work if you go 0, 1, 2, 3. Okay, so you could have said column 3 in here, and it would be the same thing. So again, if expression is more than 200, and because they want both to be satisfied, and then you pull in your function, which is AT content over here, and your sequence is then added to there, because the sequence here is being taken from your file. So you're going to say, it's going to loop around, and it's going to say, every time it gets to sequence in the file, then you're going to put that sequence into the function. You're going to call the function on that sequence. Okay, I'm trying to say it in both layman's terms and programming jargon. So you're going to call the function on that sequence, or in layman's terms, you are going to open the function and ask it to check the AT content of your sequence. And if it's less than 0.5, then it's going to print whatever they want you to print out the G names. I'm saying I'll do my own thing. So I just want to see if it all works. So I print G name, expression, and AT content of the sequence. And you will see, you should get that answer. Okay, so there was only one that satisfied that, so it printed that. I showed you that if you didn't want to use the function, you could do it that way as well. It's slightly different, but you can have a look at that. If you've done it this way, it should also work. Okay, as long as you have a for loop, it's going to calculate the sequence length, it's going to calculate the AT content for your sequence, and it's going to print out. So you don't have to use a function if you don't want to, but it's neater usually, and it's good practice. Okay, so the first example, so we've got I'm going to show you a few more. So the first one is a complex condition. And again, I'm not gonna get stuck on this one because it's all exactly the same. It's just printing every time. It's just 1 or 2 lines that's changing. So all they want you to do is to print out the gene name if it starts with a K or H, except those for melanogaster. So obviously now you know that there's going to be or statements and there's going to be and statements. And again, like I said, make sure that you know what goes in brackets. Here, this part all of this should be in brackets because these two can be or, but even if you do find one with a K, they also want you to check the condition over here that says it should not be from this particular species, Drosophila melanogaster. They also want you to do the same for H. Okay, so this is or and this is and, not. So you're negating it. And then, yeah, you should see that you shouldn't have Drosophila melanogaster in here. And then the 6th example asked for each gene. Now again, this is already giving you an example that this is going to be a for loop. Print out a message giving the gene name, and that also says whether the AT content of that particular here you should know that you're probably going to need, so you already see that you need the gene name. Are you going to calculate the AT content? You know that they want you to pull out the sequence as well. So if it's greater than 0.65, you have to print as high. Any message that you want that just says that the gene is high, AT content is high. So it's going to be accompanied with either the name high, low, and medium, depending on whether it falls within those conditions. So here again, I've used the function called AT content that takes in DNA and it does all the calculations and returns a float with the AT content. Then you do your for loop, and all of this should look familiar. You're pulling out species. I don't know why I'm pulling out species. You don't need to, but yeah, like I said, I like to print my own thing. But basically, the only thing that you need here is the gene and the sequence, because you need the AT content. So yeah, then this is an example where they wanted you to have practice with the if and the elif statements. So you're going to say, use this function that we've created here above. In the for loop, every time you get to the sequence, put the sequence, your DNA sequence, into the function. If it's greater than 0.65, print gene name, which we've defined there, and AT content is high. If it's below, now you might have written it a bit differently. I'm going to give an example in the next exercise, the last one. But the most logical way to do it is to say if it's more than 0.65, print it's high. More than 0.45 and less than 0.65, print it's medium. And if it's less than 0.65, print it's low. Okay, so let's have a look at that. And you should have this answer, where 4 of them were medium, 1 was high, and 1 was low. So this is an example, exactly the same, except this part here was changed a bit, because I mean, there might be some of you that might have said if it's more than 0.65, print that the AT content is high. If it's less, because the way the question was phrased, it gave high first, then low. So you might have wanted to do it in that sequence. So you would have written if it's more than 0.65, print high. If it's less than 0.65, print low, or else print the AT content is medium. Okay, and you should get the same result. Okay, that's the end of the conditionals, again, have a look at the GitHub page, for which the links will be at the bottom. And have fun and just practice with conditionals, because it can get a bit complicated. And like I said, always make sure that it is printing out exactly what you think it's printing out. Put stops in place to make sure that it is printing what you want it to print. And I'll see you again next time.